So thank you all for joining us in the second half of the second day. Obviously, most of you are traveling with many other sessions. Today, we're going to present some of the deliverables, some of the solutions based on other components that you've probably experienced here during Inforce in the security pioneer track. And what's interesting in the solutions and the architecture, the underlying architecture that will be covered later, is the fact that you can actually see some tangible deliverables that protect people in the virtual world. So alongside with me will join Doron Ben-Ari from the IBM Security Division, and he will take the second part. And we'll start with some small anecdotes about other technologies that we felt made a significant change to our lives, and without security mitigation, we probably wouldn't have benefited from them. So the first one, someone want to guess what significant technology made a change in our lives in the last 100 years? Let's go there. The first one was, of course, electricity. So I think around 1890, 1892, what's known as the War of the Currents. There was a real conflict out there in the US between George Westinghouse and Thomas Edison on how to stream electricity to the streets, to the homes, and to the factories. At that time, there was no real appliances other than lighting, so it was very focused on how to stream lighting or light system into the streets. And of course, what resolved this conflict and were two things. A technology introduced in George Westinghouse activities, the first transformer that allows us to reduce current from 110 to 5, 6, 7 volts. And the other one was the fact that so many electrical injuries in the streets of New York were covered in the press at the time. So security was an issue. Security was an inhibitor of streaming those technologies to the masses. And now, in the right part of the street, you can see how those numbers were mitigated throughout the years. This is the labor of Bureau that released those numbers, I think, for the last 10 years. And electrical injuries are no longer with us. So they're still here, but the trend line is very critical here, and it's declining year over year. Remember this trend line, because it's very important when we go and check other technologies and how security is mitigated within them. The second technology that I thought is very relevant is the introduction of cars. I think in 1906, 1908, Henry Ford introduces the first, not the first, it was the third generation of the Ford model, R and S. He was very bothered about the fact that the first version was not hitting the 20 miles top speed. So when he introduced this model that actually made it to 35 miles per hour, he had to mitigate other security issues. So what you can clearly see in the left side picture, that technologies that we're very accustomed today, like EBS, ABS, airbags, monitoring radars, cameras, and other equipment, which we get as a vanilla flavor in some of the new models, definitely were not here. So an entire industry of securing driving and drivers evolved since the early stages of that Ford model. And in fact, I think the last 15 years, we can see an additional trend where, I don't know how to put it mildly, the industry doesn't believe anymore in our ability as humans to drive safely. So they split this, and we like it at Amazon very much, the shared responsibility model, and the industry decided to share responsibilities between the vehicle and the driver in a different manner. There are currently 6 mapped stages, and I think most of us are somewhere in level 2, going to level 3. The funniest thing is that you don't have to read the slide, but the more responsibility the vehicle gets as an autonomous vehicle, and the less responsibility shifted from us, the less expected in the driver, the more text you get. So once we get to level 4, we are covered with very much text, a lot of text about what the driver should not do, cannot do, will not do, and the car will take extra responsibility as we go along. It's not a great compliment for humans, but perhaps it will even reduce risk of accidents even further. And the last analogy that I found interesting, and I think connects us directly to our session today, is I think the rise of the identity theft of the multiple identities, going from physical to virtual. So I tried to find something in that neighborhood, of that time neighborhood or time period, and I found this Arthur Conan Doyle story about a case of identity where this lady of means, I think called Mrs. Sutherland, is engaged to be married to a banker, and who disappears. But he doesn't disappear entirely. He continued to correspond with Mrs. Sutherland, and she suspects that something very wrong is taking place. She tries to engage Mr. Holmes. Mr. Holmes is not that interested in that story, but his loyal and very committed friend, Mr. Watson, finds it very interesting and engages Mr. Holmes in it. Eventually, Mr. Holmes resolved the issue. He knows that the banker does no longer exist, and other inheritance of this Mrs. Sutherland are imposing his identity. But we can see as early as 1891, when this story was released, that maintaining multiple identities was an issue back then. So again, it had the crime was solved in sort of behavioral analytics, and behavioral analytics is a key theme of Doron's presentation later on. Obviously, Mr. Holmes cannot scale the way IBM Security Trusteer can scale, but again, it was analyzing behavioral and finding those anomalies that led Mr. Holmes to resolve the issue. Now we're 128 years later. Each of us has multiple virtual IDs without which we cannot survive. There is a huge demand there from a complete stranger to borrow, thieve, steal our identities and use it in the marketplace. And the same, very similar demand is out there from service provider to maintain or constantly mitigate our identity while we are on the virtual space in order to detect and prevent malware. So this is the basic digital transformation, which is, I think, a characteristic common to so many definitions of digital transformation. But one feature that they all have in common in their definition is how to address identities. So there's one only physical me, and so many mini me's or virtual me's out there in banking application, pay application, healthcare, school application, and more. So the real question is, if we are so virtualized out there, and there are so virtual out there in the cyberspace, can we assume that we have mitigated some of those risks in a way we mitigated the risk in the electricity industry when we saw the declining trend line? So not according to the FBI numbers. So the Internet Crime Complaint Center released those numbers in 2018. They did not release anything in 2017. But the 2018 report, I think, covered all the previous 5 years. And you can see that the amount of complaint is rising in a rather moderate way, I think 30% between 2015 and 2018, while the total amount of damages associated with those complaints is riding in a very different way. So if we split the average, each complaint now is associated with much more money value, if you may. What does it mean? I think it means, first of all, that we are all committed. So digital transformation is here. We all do that. We all communicate with banks and other institutes. We trust the system a lot. And we need someone to take care of those. So the service provider that we communicate with will take care of our safety net, because there is so much we can do about it. So now it's a great pleasure for me to call to the stage Doron Ben-Ari, and he will try to actually put some insights on how we can change this graph in years to come. Please welcome Doron Ben-Ari.
Okay, hi everybody. So I guess that's what I do. Yep. So my name is Doron. I'm working for IBM Trusteer. I'm managing the cloud operations group, and a little bit of overview about IBM Security and who we are. A really, really large enterprise cyber security provider, both in products and services, leader in 12 different security market segments, according to analysts. We have more than 8,000 security employees in many different countries. This brand is built on many years of acquisitions of really amazing companies, such as Trusteer, 20 plus acquisitions. And as far as services, our services arm is kind of managing or looking at 70 billion, over 70 billion security events per day. So that's who we are. As far as how we think about cloud and our framework. So basically, we look at that as a foundation question or issue as you move to the cloud, and we look at three different pillars. One is securing identity and networks. The second is protecting data and workloads. And the third one is managing threat and compliance, okay? And this is regardless of cloud, on-prem, which cloud, and so on. These are concepts. And across these concepts, we look at three different activities. One is planning. So essentially, we help companies build their security strategy and plan what is it that they need to do in order to improve their security posture. Second is actually building it and creating these implementations. And as I mentioned before, with services also manage the day-to-day operation. So this was IBM Security. Now let's move on to Trusteer. So as I mentioned, Trusteer is an IBM acquisition as of several years ago. And it's dealing mostly with, today, with identity and threat and fraud, things like that. So let's talk a little bit about threat. So first of all, this is not a static thing, okay? It's not like these are the threats and this is how we deal with it. The threats have been evolving over the past 15 years, as seen in this slide, and probably will keep on evolving. I'm not going to read each one of these bullets, but it started with, small viruses and worms that are mainly focusing on creating some small damages here and there, all the way to much more sophisticated bots, and all the way to combination of bots, identity theft, and social engineering, and actually building upon Eyal's interesting opening to this conversation. Remember these graphs that Eyal showed with the slope is kind of different. The number of events is growing, but the amounts are growing much more significantly. We can see that and establish that over the past few years because our research is showing that theft and fraud and identity crime is kind of focusing on higher value accounts, okay? So the bad guys know what they're doing, okay? Looking back at our roots that actually started with malware, so you look at the type of research we have and the type of brains power we put behind that, that would be one example. So, this example is actually showing gauze-name. So what is gauze-name? Basically, it's a combination of a damage downloader called Gauzy and a virus called NIM or a malware called NIM. Our research lab essentially coined the term and kind of detected first time in the wild the combination of these two together. They were created because the code for this malware basically leaked out in the open, and then anyone and everyone could have essentially create one, and gangs did create one, and combined, this thing stole more than $100 million from US banking accounts, okay? So, we're deep in this research and, good for us, good for everybody. These guys were put behind bars actually 2 months ago. There are a whole bunch of press releases about these guys. And right now, at least, there was supposed to be behind bars. Unfortunately, there are more of them. So if you go and dig and look and what's going on in the dark web, a lot of stuff is going on in the dark web. So you have, for example, the shift to mobile. If you can, I don't know if you can see these fine print, but you know, for ridiculous amounts of $100, $200, $500, you can buy all kinds of kits that allow you to create your own mobile malware or whatever type of attack. You can actually go out there and there is a nice, lively, open, good market for buying compromised accounts for corporates, any corporates, you know, Best Buy, Airbnb, Walmart, whatever, you name it, you can actually buy compromised accounts. Active market for gift cards, for example, so you can go and for $10 buy a Costco card with a nominal value of say $200, and so on. The list goes on and on and on. Starbucks coffee and so on. These are additional examples of the some of the research items that we've been studying and discovering in our labs. Okay. So I'm not going to go deeper in each one of them because this is a lecture for a week, not for an hour. But I picked one trend to look at, one interesting trend that we recently saw. So, and kind of talk a little bit about this trend, expand it a little bit, and show the type of research we do. So what you see here is that about, I don't know, 15 months ago or so, our research shows that in North America, mobile fraud is more common than fraud that is done via the browser. Okay, so that's a very interesting trend. You can see the blue line kind of crossing the red line somewhere around February of last year. How does it look? So here's an example. This is a phone of a victim who's actually running Adobe Flash Player application, and if you go and check, you'll find that this application does not really exist. There is no such a thing, but it somehow made its way to the victim's phone. And it's there, and it's actually a piece of malware. And what does it do? Well, let's find out. So this user is into Bitcoin and is opening his Coinbase application to check how good he's doing over there. And of course, he's being asked to sign in. Now, if you look really carefully, he's being asked to sign in, but the real sign-in request is behind the scenes or behind this overlay. So what you see is a malware that is typed, it's mobile overlay malware. It's basically asking for username and password. The victim is essentially typing it in, and this thing is not going to Coinbase. This thing is going to the criminal command and control center, and you can see it told him, hey, it's wrong. Actually, please do it again. The reason is, you might as well, when you steal it, you might as well double verify that you steal the right thing. So just ask him again to put the credentials in to make sure you're stealing the right stuff. So this is the victim kind of typing again credentials and clicking login, and guess what? You're not logging in. You're being asked to log in again to the real applications. That's kind of one type of how this thing is being done and how criminals are using the mobile overlay attack to essentially steal credentials. This is another video, and what's interesting about that one, and you know, I doubt any of you have seen this type of stuff before. On the right-hand side, you see a victim phone. On the left-hand side, what you see is essentially the criminal command and control center. Okay. So this is a piece of software that is being, let's just call it, arrived to our labs and being investigated by our security specialists. And what you can see over there is that from the fraudster perspective or the criminal perspective, once they have this phone, they have complete and total control of anything that is being done on this phone. So the bad guy, which you can see on the left, can now click on lock the phone or lock the screen. And the minute he does that, you're going to see in a second what's going to happen to the phone. They can browse the packages. They can see everything that is installed on the phone. They can send SMS to the phone. They can send SMS on behalf of the real phone user, and so on. And what you see on the right-hand side now is this is the user experience of the victim, right? So he's getting this, Android is being updated, please hold on. And at this point, he or she is a complete captive of the criminal who's working on the left side of the screen using the command and control. So they have complete control. You basically may be asking yourself how common this is. So, for example, this is how common this is. This is a very partial list of overlays that were found and detected. This list, by the way, is alphabetically sorted, going from A to Z, but all you can see on the screen here is A to C, because there's not enough space. So this is very, very common, and there are many, many such attacks that pretend to be either, Coinbase or your favorite banking application or whatnot. And then you may ask yourself, somebody's putting a lot of effort creating all of this, and the unfortunate truth is that it doesn't really take a lot of effort these days, because everybody here in the audience know what is software as a service and infrastructure as a service and platform as a service. So guess what? Fraud as a service. How about that? You don't really need to invest a lot to do this kind of stuff. You basically go and buy a kit on the darknet, you customize it, you basically tell it who are the victims, what sites you want to attack, what type of overlay application you'd like to build, and so on. Think about the customization wizard, and that's it. Very quickly, you get your app, and you deploy the app. These examples are coming from the Android App Store. It could be a flashlight. It could be a financial application. But really, this application that you've been downloading essentially actually put the overlay attack on your phone for next time you use your banking app or Coinbase or whatever. So overlay is one example, right? I mean, there are many other examples. Smishing is another one, right? Smishing is the marriage of SMS and phishing. You get some sort of SMS message, contains a link. You click on the link. Guess what? It takes you to some bad site that was developed and created by the criminal. You don't know that, so you're going to put your sign-in information. In fact, you're being requested many times to put much more information, and that's it. It belongs to somebody else now. Somebody else has that. So these things constantly evolve, and as they evolve, our solutions evolve hand in hand. So Trusteer started as a agent running on your PC, Windows, Mac, Android, iOS. Today, what we're really focused on, all the way to the right, is our Trusteer Pinpoint Verify product and Trusteer Pinpoint Assure. And what these products do, they essentially focused on digital identity trust. Okay, and when we talk about this term, we're essentially talking about loss prevention and keeping the bad guys out. We're talking about protecting your identity, which I'm going to talk about in the next few minutes, trying to make it frictionless, because protecting identity and making it really, really hard on the user, that's easy. Question is how to protect identity and make it reasonable or actually excellent for the user. And the last one is compliance, privacy, GDPR, open API, etc. So how do we do all of that? I talked about what do we do, so now let's talk a little bit about how do we do that. And this will touch a little bit on Amazon and how we deploy on AWS, etc. So the way it works is, think about a really big data lake, and we collect data from either your browsers when you do online whatever, shopping, online banking, online insurance registration, whatever, via the phone or via the browser. We do offline research on the data collected, and in real time, we provide risk assessment to whoever is our customer. So this little red roof shop over there could be a bank, could be an insurance company, could be a healthcare provider. They, in real time, will consult us and say, what is the risk in this session? Is this really whoever he claims or she claims to be? So, let's look at that and understand what's in this circle, what's in this data lake, okay? So the data lake stores a really wide array of data types. And when I say data types, I do not mean string, float, or integer. I mean the types of information we collect in order to do the magic. So we're collecting information about users, information about their behavior, information about their devices, the context and environment they operate in, and their activity over timeline. Okay, so looking at that, you can split it. You can look at that in all kinds of ways, but one way to look at that is we have a bunch of what we call familiarity signals. Okay, how you behave, what's your device, what is your typical geolocation. There are a whole bunch of other signs that we call the crime logic indicators, and these could be, was there a SIM swap on the device recently? Did we detect a bot or a suspecting of detecting a bot? Was the device spoofed, and so on and so on. On top of that, many of these items have long history context, so we don't just collect it once, we collect it over a long period of time. And then we combine that with the last layer here, which is intelligence. Okay, so we're talking about a lot of information we gathered over the years, and we keep on updating almost on a daily basis. And we're talking about hundreds of or tens of thousands of lists of phishing sites, of malware configuration, of samples, darknet data, and so on. So you combine, and usually none of these boxes that you see here can stand alone as a single identity indicator. But combining all of that is giving us the edge that we're looking for. So we discover identity and build trust. Why do we do it? I talked about that before. Cross-digital visibility and control, transparent real-time authentication and fraud detection, and user-friendly authentication as much as possible, as well as compliance. I'm not going to read each one of these lines. The materials are available, and by the end of this conversation, if anyone would like to ask me anything, I'll be available out in the hallway. So let's talk a little bit about Trusteer, how we're built. Okay, so our main product is deployed on Amazon. We also have research facility in our own internal traditional IT private cloud group. We are also using the IBM cloud. We talk to the IBM cloud, and we're using some third-party tools that, within themselves also are cloud deployments. With respect to Amazon, we're spread across multiple regions. The reason we're spread across multiple regions are two. One is for performance and being close to our customer base. And the second one is obviously compliance. So for example, data in Japan should not leave Japan, GDPR, data in Europe stays in Europe, etc. Okay? So this is how we're spread. In terms of Amazon services we're using, this is a partial list. So we're using, basic infrastructure stuff like, VPC or S3 or storage. We're using database services such as RDS. We're using, recently we started using machine learning services such as SageMaker, and of course, also a bunch of services related to security and compliance like CloudWatch and CloudTrail and HSM and key management and so forth. Okay, so all of that was kind of between Eyal and myself. This was like a half-hour introduction. And at this point as I prepared this talk, I realized there are two interesting stories to tell here. And I thought, which one should I be telling? And of course, I decided to tell both. So we'll try to focus on two different stories right now, okay? So story number one is about fraud and identity and, how do we do it? Okay, so let's start with story number one. So story number one, this is the capacity we operate in, okay? We have around 40 million unique users we protect every month. All of these numbers are monthly, by the way, okay? So around 40 million unique users. This translates to 1.2 billion sessions, essentially a month. And when we say session, it's somebody logging in via browser, via mobile, performing some sort of activity, and then, in the end, will log out. Now, keep in mind, a session, as I just described, is not something that will take 2 seconds. It takes some time. And throughout the session, things may happen. So you log in, it's an event. You browse from one page to another, it's an event. You go and add a payee, that's an interesting event. You go and empty your entire bank to that newly added payee, that's a really interesting event. And so we basically collect these events throughout the session to be able to understand what's suspicious, what not, and where is it, which is the point where the risk is becoming too high. So these events are being collected on every session, and when you actually look at events, we're talking about 14 billion events per month, okay? All of this data is stored in a data lake, as I explained before, and we have a few of these depending on geographies and regions and compliance. So, you know, one in Europe and one in US, et cetera, et cetera. And these data lakes are essentially or our product is essentially approaching this data on every API call. And to be a bit more descriptive, an API call might be the bank asking about a session, how risky this is, what is the likelihood of this session that is claiming to be Doron to be really Doron, okay? So that would be an API call, and we're talking about a load of approximately 500 million API calls per month. And if you actually want to go and grind it to the level of HTTP calls, we're talking about almost 50 billion per month. So you look at all of these, you know, all of these numbers, and the question is, okay, so how does it work on the Amazon infrastructure? I kind of described what it is. I didn't talk about how does it work. So if you look at the slide I already showed before, that's kind of a conceptual block diagram of data being collected, being put in a big circle, being researched, and being used in API calls. If you peel off the circle, you can actually see the key components of the underlying infrastructure. Okay, so this is a typical Lambda architecture where information is being collected and is being essentially sent into two different layers simultaneously. One is called the batch layer, and the other one is called the speed layer. The batch layer is, just as it sounds, would process this information, convert it to proper data structures, and store it in an S3 bucket we call the data lake, okay? But the information at the same time is being collected and being sent to RDS, MySQL, that is storing only recent recent history. So we're talking few days. And so when an API calls is happening, and here you should be looking at this red-white roof thingy, which is, again, the bank, the insurance company, the healthcare provider, they would basically approach us with an API and say, what's the risk? Is this really who he claims to be? And we basically take the recent information from this 3-day RDS database and the full year information from another database, which is implemented with Cassandra, merge it in runtime, and based on the insight of really short history and long history combined, we can basically say, yeah, you know, the risk level is, you know, there is a good chance, 70% chance that this is not who this person claims to be. At which point, the Red Roof shop can decide to send you an OTP request or verify your identity or block you out or do something. Then there is also, on the right-hand side, the yellow area, which we call the offline research layer. So over there, you approach the various data pieces that are collected in S3, and essentially, not in runtime, but offline, perform your research. Develop insights, understand trends, figure out new things, and basically come up with new ideas and new solutions to the problem. So this is kind of the main building blocks behind the scenes. And let me now take you through some of the interesting things we do with the data. So the framework for authentication, I'm sure this is not new for most of you. So something you know, something you have, something you are. And I'm not going to talk about each one of these bullets. I'm actually going to focus on one of the interesting ones, okay? So on the right-hand side, there is something you are, and you can look at behavioral over there. And each one of these bullets is developed and evolved in Trusteer to many different points. So let's dig on behavioral for a minute. So you look at behavioral biometrics. What does it mean? It means that we're tracking and collecting a whole bunch of information that allows us to say what is the likelihood that this person is, you know, really the person. So this would be the way you move your mouse, the way you touch your screen, the way you use your keyboard, how you navigate across web pages and how much time you spent on them. And I'll show you one fascinating example. So right now you can see two videos playing. And they're looking at mouse movements of users performing online banking session. And as you look at that, because we're all smarter than the machine, despite of all machine learning, we can see significant difference between the upper picture and the lower one. And if you carefully look at that, anyone can take a guess. What's the upper one, the lower one? Wild guess? Say again? Upper is human. So the upper picture is human. So this is a human moving the mouse. We capture mouse move events and process this in real time and basically say, this is a pattern of a person. You look at the lower one, this is a fraud session. And how do we know it's a fraud session? Because A, it looks very different. The reason, by the way, it looks very different is because of mouse click delays that are introduced by remote access tools that were put on the user's machine. You can also, if you actually look really carefully, you can see red and green arrows for start, end of mouse moving. And you can see only one start and one end on the upper one. On the lower one, you see many of them. It's also a longer session, which probably means that this was one of these sessions where somebody called the victim and said, hi, I'm Joe from the bank. Can you please do this? And can you please do that? Now stop. Now I'll do this. And basically kind of social engineering attack that where the criminal convinced the victim to do some things and then took over, did some other things, etc. So it's very different. And this is some of the things we detect in real time. Another one would be keystrokes. Okay, so the way we use the keyboard is very unique to us. Okay. So even if I gave you a sticky note with a username and password for an account and ask you to log in, each one of us will basically use it differently. Why? Because you may be using the left shift key to capitalize and I would be using the right. You may be using the numbers on the top bar of the keyboard and somebody else may be using the side numlock kind of area. So you look at how people use the keyboard, that's yet another telling sign of who they are, as well as the speed of hitting the keyboard, as well as hitting the button and releasing the button. You put it all together, lots of data. You do big data analysis, and essentially you can come up with good signs of who this person is. Another one, and that's a much simpler one, is page flow. How did you flow from one page to the other to the other? So it's very common to get to certain pages from other certain pages. And if you just happen to land there, it may be actually a sign that you're not who you claim to be. So these are different ways of doing behavioral biometrics. I'm going to also talk a little bit about different ways of where we detect stuff. So for example, detection. You look at detection. RAT, remote access tool, okay? You look at the graph indicates a point of activation. So what does it mean, the point of activation? Very similar to the videos we saw before. The minute a remote access tool is being activated on the victim's machine such that the attacker can do banking or whatever activity instead of them, a delay is being introduced to mouse moves and mouse clicks. So you can see in this graph, it kind of spiked from 20 milliseconds to almost 200 milliseconds. And it's a very clear telling sign for us that something is wrong with the session. Again, this could be okay. This could be me helping my mom who called me and said, please help me with something. And I take over with some, I don't know, Skype or whatever and do something. So this is just one sign. And you need to combine it with many other factors to create a good indication. But we do that. And of course, as we are able to detect that and as we're able to stop criminals this way, they kind of scratch their head and say, well, okay, maybe this idea of the remote access with the mouse move is not so good, so let's stop moving the mouse, okay? Let's just work with tab and keyboard tabs and jumping across fields automatically without moving the mouse, great idea. And so again, it's an attrition war. We come up with some other mechanisms. So the minute they do that, you can see that the density of events is changing dramatically as they activate their crime logic. So in the screen above, I actually chopped off the name of the distinguished financial institution that basically got hacked with this crime. So this is a real thing where I chopped the name of the institution. It's in Spanish. Basically, it's a screen asking you to put your digital password or something like that, but it's not really the banks. It's a copycat. It's the bad guys creating software that looks exactly like the bank software and kind of triggering this at the right moment to steal password. And how do we detect that? Again, the mouse move stops, and what you get is a lot of mouse clicks, but no mouse move. So that's yet another telling sign. So this is kind of, I said I'm going to tell you two different stories. So this was kind of story number one. A little bit about our architecture on Amazon, how we do it, what data we collect, and what do we do with the data, okay? So story number two. Story number two is also an interesting story for in the context of this event and in the context of security. So we're running a big operation, right? I mean, at least in my world, this is big. These are the numbers, the monthly numbers I showed before. A lot of activity, a lot is happening on our cloud. And this is not stable. And when I say this is not stable, I'm not talking about the malware evolving or the type of threat evolving or how identity is being stolen evolving. I'm not talking about that. I'm talking about changes happening in Trusteer. So we have new software releases coming out. We have new crime detection logic coming out. We have obviously patching activity to our infrastructure coming out all the time. We have bug fixes. We have everything. And so you look at all of these changes combined, we're looking at dozens of changes per day to the degree that some creative people in my team came up with a homegrown tool to be able to visualize all these changes across time and across multiple teams. And these changes happen all day long, every day. Okay, so this is 24/7, 365 happening all the time. What you see on the graph on the right-hand side is a typical business day for many businesses. I'm sure some of you may have seen something like that before. So nighttime, no load, morning, the business is waking up, people start to log in and do activity. It peaks over noonish and then kind of sloping down all the way back to night. And the white lines basically indicate a change event on our infrastructure. It could be a release. It could be new business logic. It could be a patching activity. It could be new types of software or whatever. So this is kind of happening all day long, regardless of time and load. And it's kind of extreme. So I'm in the industry 20 years or so, and I think when I started my career, I still remember waterfall happening. So there was waterfall and agile and DevOps, and I think what's happening in Trusteer in a business like that, it's kind of, it does not have a name yet, but it's DevOps taken to the extreme, because the changes are at a scale, at a hyper scale that does not really have a name. So the key question is, how do you keep all of this secure? So it's big, a lot of stuff is happening, all the time, and you need to keep your own operations secure. So I already mentioned, we use some of the Amazon tools, CloudTrail, CloudWatch, HSM, Key Management, and a few others. And we use some enterprise scale, enterprise grade tools. And yes, being part of IBM makes it easy, because you're able to access good resources on how to use that, but they're available to everyone using this. So the first one, and this is probably our kind of a heavy gun that we use to protect our own infrastructure, is QRadar. So QRadar is IBM SIEM solution, allows you to gain actionable insight and react quickly to what you find. This is taken from the website, but preparing to this talk, I looked at this slide and I said to myself, very interesting, because at the lower part of the slide where it talks about the value. I think we're using QRadar to do all of this. So detect advanced threat, detect insider threat, and I'll show some of that, protect data, address GDPR, secure the cloud, address compliance, all of this. So this is our tool. This is what we use. For those of you running on Amazon, the tool is available for you to use in Amazon in two different ways. So on the right-hand side, it's available on the IBM site. You can download and configure. And in fact, the Amazon AWS CloudTrail connector to QRadar is well documented. It's a kind of a best practice, and you can actually configure this rather easily. That is, in fact, the way we did it in Trusteer. We've done it years ago. Since then, the market has evolved, and QRadar is also available on the Amazon Marketplace as a bring your own license setup. So essentially, setting up and using QRadar on Amazon is kind of easy. You can do it either as described in the left side or the right side, but well documented and well understood practice. The way we do it in Trusteer is what you see here. So on the lower part of the slide, you can see those 8 regions I talked about. So these would be, Japan, Sydney, US, East, West, whatever. All of these regions would send events from Amazon, CloudWatch, CloudTrail, EC2. A whole bunch of events are being piped into the QRadar instance. We're talking 5K events per day, and these events are being scanned and monitored by more than 100 different compliance rules. Now, here's the kicker. All of this thing is generating about 10 info messages a day for us to look at, and one dramatic message that you go look at it now, okay, to our SOC team. And how is this achieved? We have a low false alert volume, and it's achieved by using a combination of all kinds of methods. Okay, so first of all, we're using really smart rules, not naive ones. So you're basically considering time windows, who's the user, what's the IP address. You take a whole bunch of repetitive alerts and kind of condense it into one alert with sub-items. By doing all of that, you can actually reduce the workload on your SOC team. We're also using an add-on called User Behavior Analytics, which I'm going to show in a minute, that focuses on user behavior analytics. And we're using a mixture of rules. Okay, some of them are out of the box coming in QRadar, and some of them we develop ourselves, custom. This is a QRadar graph showing security events from Amazon. And without, you don't need a magnifier glass to see that something strange is going on. Right smack in the middle of this graph, you see a pile of these green events, and these green events are actually, they relate to specifically between 4 and 5 a.m. in Europe Central region in Amazon, something was going on. So again, this is a QRadar graph. It's showing Amazon security events and allows you to analyze that. Another interesting view is this one. So I talked about that a minute ago. This is the user behavior analytics screen. So what you see here are essentially 3 alerts, each for a specific user. And for example, the top one that is marked red is showing you a user that is accessing an S3 bucket that is supposed to be accessible only by applications and not humans, but this is a human. So that would be one, one such example. Okay, so this is a kind of a user-centric view. Another tool we use, so that was QRadar. Another tool that we've been using for quite some time very successfully is BigFix. So BigFix is essentially an endpoint management security tool. Allows you to look at the compliance, inventory, patching level of everything that you have deployed. So the pattern, if you look at that from a pattern perspective, it's kind of similar to the QRadar pattern. So all of these Amazon regions, 1 to 8 that we have, basically send information to BigFix, but this time these are not events. These are kind of the status level of each one of the software as compared to advisory services of patching level. And as security professionals, we all know that just keeping all of these systems patched to the right level, A, is really big effort, and B, is really, really important, okay? Because a lot of bad stuff is just happening because your systems are not patched up to date, okay? So this is a critical, critical aspect of how we do our business. From the Amazon Linux Security Center, basically we wrote a small connector connecting this Amazon Security Center that is shipping outside all these CVEs and vulnerabilities and so on to the actual versions that we deploy on Amazon, compare the two, and if something is missing or there is a mismatch, this is being shipped to BigFix as a piece of information. And we're looking at BigFix both for the Amazon cloud as well as our on-premises operation, okay? This is how it looks. So this, for example, is a screenshot of, I don't know, a few days ago. Basically, it tells you that you're 93% compliant, and how is this being calculated? You can see in the slide that it says you have 2,795 computers, you have 222 checks running on each one of them. They're grouped into groups of checks, so it makes some logical sense. And the product of these two numbers is, I don't know, a few 100,000, and 93% of them are good, which means you still have 7% to work on. This is how the checklist looks like. So if you basically look at this thing, you can see that the computer names are blurred out. We didn't want them kind of out there, but for each one of the computer, you can see if it's compliant or non-compliant, as well as a small timeline that shows you green and red, kind of when did this compliance problem started and when did it end and so on, as well as what is the missing CVE or, what is the missing patch or what needs to be done to resolve the problem and what problem it is. That's another view of the same thing. I talked about these checks organized in checklists, right? So the upper picture is a screenshot of some of these checklists that organize all of these rules into something coherent and that makes logical sense. And the lower picture shows a drill down on one of these checklists where you can see each one of the checks. On the right side, these are your compliance metrics. Are you 90% good, 60, 99, whatever. So this is another tool we've been using for a long time, and it's kind of one of our foundation tools. Other tools that we are now in phase of prototyping and checking our implementation. The first one is Resilient. So that's another IBM tool where essentially, if you take a look at the upper left box, it says QRadar, right? It can say many other things like Splunk and ArcSight and whatever SIEM tool. And essentially, information is being collected or sent into the Resilient tool. And what you can do in Resilient is essentially orchestrate and automate your response. So you can actually build your entire flow of what needs to be done upon certain security events in order to resolve. Could be manual, could be automatic, and could be a combination. And when I say automatic, you can actually automate that also using Amazon APIs if you happen to run Resilient on, in order to keep your Amazon infrastructure secure. Lastly, another tool we're kind of in the very beginning stage of kind of considering how to use that for our own purposes is Guardium, another tool, an IBM tool that is essentially looking at data protection to a very high level, a nice level of granularity to the query level, who did query on what and why and when, both in terms of reporting as well as blocking. And just like QRadar, in terms of setting it up, kind of easy because it's on the Amazon marketplace. Now, last but not least is this thing. And what's interesting is that what we've discovered over the years is that regardless of whatever tools you've been using, QRadar or BigFix or whatever it is that you're using, any commercial tool, you always have these little gaps where you need to kind of write your own little thing or your own little check or augment your security enforcement in some other way that is kind of does not exactly fit in this tool or that tool or the other tool. And so we basically augment all of these commercial tools and solutions with some homegrown tools. So kind of building our own dashboards that will either present Amazon metrics or QRadar metrics or whatever metric that we decided is important for us to keep our own cloud secure and does not show up in any other tool, we basically write our own thing and show it in our own little dashboard to basically keep ourselves safe and secure. So this is kind of a visual of a dashboard. You'd be surprised, but green is good and yellow is not so good. And when red comes up, it's really not good. Okay, so this is visible to both the operation team, R&D team, risk officer, compliance team, SOC, etc., allowing us to improve essentially. So that kind of concludes story number 2. So to wrap up, basically, as Trusteer, we have this long heritage of deep insight from fraud and malware all the way to social engineering and credential theft and identity corroboration. We're basically running on Amazon. This is where we have our data lake, and this is where the risk engine is running. And we have some research facilities and other facilities running on-prem, and the whole thing is kind of working together with a unified view on security for our own security. Okay. As far as how we do it, as I mentioned before, we augment Amazon native security features with a whole bunch of enterprise scale tools that we have in IBM, primarily QRadar and BigFix, and also Resilient and Guardian to come. So that kind of wraps up story number 2. I hope it was interesting. I'd like to thank all of these people that are listed here, but I also would like to thank many of the research teams in Trusteer that put together these type of materials, the DevOps team that built the security setup that you saw, and the Amazon team that invited me to show up here in this lovely day in Boston and talk to you guys. And surprisingly, we also have 2 minutes and 35 seconds for questions. Anyone? No. Okay, have a good one. Thank you.